Hi, my name is Steve North and the title of this talk is Yay or Nay, Co-Designing Systems with Horses, an Animal-Computer Interaction Perspective. So, this is me with my horses. Let me just tell you a little bit about myself. I'm primarily a computer science researcher, mainly working in a field called Human-Computer Interaction or HCI, with a specific focus on Animal-Computer Interaction or ACI. I'm also a natural horsemanship instructor with some animal behaviour ethology and horse training experience. And I'm particularly interested in what happens when animals, human and non-human, use technology that they're unaware of. For example, it operates without their knowledge or they're cognitively unable to understand its purpose. And through a project I'm going to tell you about Habit, which is Horse Automated Behaviour Identification Tool, I'm researching horse-computer interaction, so looking at one particular species, focusing on automated behavior identification from video. And you could say that my main focus is using technology to give the voiceless a voice, be they human or other animals. So some of my previous work it's tended to be based around using quantitative ethology, that's animal behavior based approaches for the analysis of human animal interactions, particularly through the Habit project, which I'm going to tell you a bit more about later. And also another recent project, Pirelli versus ISIS. Now, Pirelli is a popular natural horsemanship. Yes, and they do use horsemen, even the women who are involved in the program. It's a training program, and ISES is the International Society for Equitation Science. And this was a project about evaluating less orthodox horse training programs like Pirelli against more established traditional type horse training procedures, as many people who are involved in ISIS would be doing. And it was tried to compare something which is seen as a bit of an outsider, Pirelli natural horsemanship, against evidence-based good practice in equitation science, and it was using computer-based logging to capture behaviours in the training program. So there are commonalities between these two projects. They're both about video analysis and they both use ethograms, which are descriptions of behaviours, usually for a particular species, but you can also apply them to a species or interspecies behaviour in a given environmental situation. So human-computer interaction, HCI, is unusual within computer science because it tends to use ethnomethodology or ethnography more in the same way that perhaps anthropology or anthrozoology would. If you have a look at Blackwell, Blythe and Kay 2017 in my suggested reading list for this presentation, there's a lot of explanation there about how that came about in computer science, how computer science, how human-computer interaction, as distinct from many other areas of computer science, tended to have quite a qualitative approach to analysis as methodologies go. Because I came from that background, my use of quantitative ethology-based approaches such as counting behavior frequencies, statistics, etc. is quite unusual in human-computer interaction. My research interests are primarily around giving voices and choices to animals, including humans, when encountering new systems, whether they're technology-based systems or otherwise. And following on from my previous projects, I'm interested now in hybrid methodologies which combine elements of quant and qual, and developing software for automated behavior recognition using techniques from computer science called machine learning and computer vision. This is largely what I was doing under Habit, and I'm trying to bring some of that into ease and work here in Athrozoology. Okay. So what are we going to talk about during the presentation? What is animal-computer interaction, which is the subfield that I tend to work in? Principles for co-designing with other animals, because ACI is often about designing systems with and for animals. ACI methodologies, as they have some relevance as well to anthrozoology. The Habit project, my horse-based work, horse-computer interaction and its objectives. And also I want to talk about implicit and unaware system interactors, which I'll explain a bit more about later. You don't need to know what that is right now. What is ACI? ACI stands for Animal-Computer Interaction. It looks at the relationship between animals and technology, including enrichment technologies directly used by the animal themselves, such as elephant toys in zoos, cats playing with tablets playing hunt games, improving the lives of working dogs in areas like cancer detection and things, and welfare monitoring tools for animals. Now, animals interact with our computer-based systems whether they know it or not. This is some of the referring back to implicit and unaware interactors. They don't necessarily know where they're doing it, but they are often working with our computer systems. The lack of an animal perspective on system design can have negative effects on both the animal users themselves and the purpose for which the animal technology is developed. There's no point in developing something if it turns out that because we've not really thought about what would be good for the animal, we've actually designed a faulty product. And if you want to find out more about ACI, a good starting point is Clara Mancini's paper, which was from 2011, which was a fundamental paper in ACI, and Clara Mancini is one of the partners in Habit. ACI and its focus. It studies the interaction between animals and technology in naturalistic settings and around specific animal activities or interspecies relations, developing user-centered technology that can improve animals' welfare and support animals in their activities, informing user-centered approaches to the design of technology intended for animals, derived from both interaction design and animal science. And of course, quite relevant to the course you're doing, and also EASE, the EASE working group, ACI and ethics. Previous ACI conferences have considered things like animal technologies that do or do not constitute good examples of or models for animal-computer interaction, legitimate technological applications for ACI, implications of ACI's animal-centered perspective for conducting research that involves animal participants. Thus far, ACI researchers have tended to be animal allies. They tend to have an interest in the enrichment and welfare of the animals that we work with and for. My guiding principles for co-designing with other animals, and these are things that we've discussed within ACI, but this is my take on it. Our commitment to other animals should be build only what they want or need. Avoid researcher self-deception such as, of course my parrot wants to play virtual reality golf, which is also known as the unconscious projection of personal design priorities and enthusiasms onto voiceless co-designers. So we get ourselves excited thinking about what we can do with the technology, and sometimes it's easy to put the animal second and just think, well, of course the animal's going to want to do it. That's something to avoid. Try to embrace when you're working in ACI and you're thinking about designing systems for them, methodologies that genuinely elicit animals' requirements and their responses to our technological solutions. And it should be said that for Athrozoology, in this, for co-designing, you might want to read co-researcher and informant. The ethical issues are similar. I would argue that a lot of the principles still apply. We need to be careful not to deceive ourselves that we're doing something that's actually in the best interest of the animal. Before going into the next slide, and as horses are my particular species of interest, I'm going to now consider them in a bit more. Historical horse technology interaction. Before 4000 BCE, humans ate horses. Between 4000 and 3000 BCE, humans started to use horses for traction and transport. They were still eating them too. The start of horses having to interact with our technology, that was also happening then. And then there were the hard technologies. So this is not the soft technologies that we're talking about now, like computer-based stuff. I'm interested in the interaction between animal species and all forms of technology, as well as just the very recent ones. So it's not just the digital era technologies, but it's interesting to look back as well. These are things like saddles, bridles, reins, bits, halters, whips, working collars, harness, chariot, cart and plough. And arguably, some would say the most significant, the hot shod metal shoe. Although many people now might dispute this, there's a barefoot movement. My own horses are barefoot, and it's now thought that there were other reasons why horses perhaps had to wear shoes that were more about the way they were kept and their physical health than about increasing their endurance. The horse was a primary driver of human technological development, arguably. Humans could now travel great distances, carry cargo, trade, and share both languages and culture. Moving forward to modern horse-computer interaction. Example system categories for this might be environmental, physical training, health, and sports performance analysis. Under health, we have things like pregnancy monitors from webcams. Horses that are pregnant can be fitted with monitors so that human can sit safely tucked up in bed waiting for a text to tell them that something has happened in the physiology of the pregnant mare, suggesting that she's about to give birth, so that they only have to come or turn on their webcam to have a look at that point. So it kind of distances the human slightly from the animal companion. In physiological monitoring, there are common ways to track a horse's level of stress, things like including heart frequency variability, salivary cortisol levels. This type of monitoring allows humans to understand when a horse is relaxed and therefore likely to be within its comfortable repertoire of behaviours. In the habit approach, where we're not directly connected to the horse with equipment, what we're doing is for monitoring them is non-intrusive, so we don't need to take samples or attach sensors or interfere with the horse's normal behaviour. This has got obvious advantages where horses are being studied, or if they're feral, unused to humans, etc. And I'll talk a little bit more about that when we get to habit. So here's an example of modern horse-computer interaction, and I've said, is this okay? Now, I don't think this is a good example, but it is an example of how horses are increasingly coming head-on into contact with our computer-based technology systems. This is something developed by Kurt System. It's fitness training for racehorses, and they claim it's designed to introduce young racehorses to training gradually under a pre-designed racing program. The horse isn't pulling the 4.5-ton vehicle, rather the vehicle keeps pace, and trainers fit the horse with equipment such as an electrocardiogram machine, oxygen masks and movement sensors to monitor its performance. They can then subtly regulate the horse's speed for optimal training. However, horses are tethered within cabins that are powered by an overhead monorail. The speed can be set from walk to canter around an oval circuit of just under a mile. The training can also be closely monitored on closed-circuit television. Now, I have concerns here that horses may be forced to keep up. The company claims there are safety features. That the humans are further removed from the equation. It encourages the further commoditization of horses for the racing industry. Without strong relationships with human carers, the grooms and things, as well as the jockeys, although they don't see them very often, racehorses may become even more disposable. So this is not a system that I feel comfortable with, but it's an example of the way things may be going, particularly if people want to increasingly pass over the training of their animals to machines. Is this a good thing? So I mentioned some guiding principles earlier. How do we actually get from them to some sort of practice? How do we put a plan in place? How do we build only what they want or what they need? Well, one way is to make sure we're embracing the otherness of animals, and that's by developing techniques to enhance empathy with animals, so that designers, human carers can put themselves in the place of the animal and really think about what the animal might want or need, the non-human animal obviously, although it does apply to human animals too. Also, techniques that challenge both human exceptionalism and supremacy, and also the pigeonholing of ACI as an outsider activity. Although these things are beyond the scope of this talk, there's an awful lot we could say about that. But as a research area, ACI often has to defend itself from being viewed as a sub-area of human-computer interaction. So you have human-computer interaction at the top of the pyramid, and underneath it somewhere you've got a little arrow going down to animal-computer interaction. Now I think this may be only a subtlety in a case of organising things into some sort of convenient class structure, but I say why shouldn't it be the other way round? If humans are just one of many species, then surely human-computer interaction is actually a sub and potentially niche area of animal-computer interaction. So other ways that we might try to put our principles into practice, how about developing a new hybrid approach that more represents the interdisciplinary nature of ACI? That way we can make sure that we're finding the most subtle possible ways to represent the needs and wants of the animal, in my case horses. So addressing the first of those, put yourself in their place. Now here's something that people in ACI have written about sometimes. This is also borrowed from the HCI field, the idea of design fiction, which is sometimes known as speculative fiction. Design fiction is a term coined by Bruce Sterling, who's known as a science fiction writer. He wrote things with William Gibson, including what's considered to be the first steampunk novel, The Difference Engine. He wrote in 2005 in this MediaWorks pamphlet, Shaping Things, he defined design fiction as 1, something that creates a story world, 2, has something being prototyped within that story world, and 3, does so in order to create a discursive space where something may mean anything. So let's look at an example. This is from something I was writing up. This is an example of design fiction for horses. So this is called Self-Carriage, the autonomous self-driving trailer. This is a conveyance for horse-pleasing excursions. And in my design fiction, I have a character called Blaze, who is a fictional equine co-designer. So Blaze has told us that he'd like to visit previous herd members and sites of special equine interest, such as historic grasslands, national parks, etc. Without a driving license, he'd like a system designed that would allow him to climb into a self-driving trailer, transport him automatically to his destination. So this sketch is adapted from a traditional UK horse trailer design, usually towed by a car. A fifth wheel has been added to the front of the trailer, and this vehicle is imagined to comply with level 4 of the US National Highway Traffic Safety Administration formal classification system. That is to say that the self-carriage will perform all safety critical functions for the entire journey, with the horse not controlling the vehicle at any time, including stop, start, parking, etc. It features LiDAR, a laser rangefinder, which uses an array of beams to create 3D images of objects within 200 meters. It's also got a front-mounted camera, which would see objects immediately ahead of the trailer. In addition, front and rear radars would ensure a safe distance between the vehicle and the road users. An aerial mounted on the trailer's roof, disguised as a curved cross member, would provide very accurate positioning information, GPS. This would feed into the sat-nav used for route planning. There's an interface touchscreen on an inside wall of the trailer. This allows the horse to select a destination from a scrollable, zoomable map. The horse's nose is used to navigate the map and to select the destination. Here's another example. This is called Backs to the Wind Boys, a weather-responsive shelter for the British climate. So Blaze is involved in this project as well. Blaze and his herd have free access to a field shelter building. Conventionally, field shelters are placed in a fixed location, optimizing the known weather conditions for the site. Usually the shelter is positioned with its doorways away from the prevailing wind. Blaze wonders if technology might be able to improve this situation. He'd like a shelter on a revolving pedestal, which can be moved either by motor or allowed to freewheel in the wind. He's heard that similar summer houses have been built for humans. Usually these have to be rotated manually. This shelter will have 5 modes: wind avoid, wind seek, sun track, shade track, and lock, which will fix it in a position as desired to see a particular vista. All of it's controlled by a nose touch interface panel sited inside the shelter. And there's a little at the front of the diagram, you can see in the expanded detail of the panel, the very simple icons that the horse would have to learn how to touch with its nose. You can see as well we've got the wind vane that controls the direction so that the shelter can automatically move into the wind. Solar panels mounted on the roof to power everything. So there we go, that's back to the wind, boys. So how could this be practically used to design systems for horses and other animals? Obviously it's a little bit flippant, but firstly it's just a thought exercise to help designers develop empathy for other species. What do they want and need again? But of course that's not the only way that it could be used, and that's very important in its own right, where being able to put people in the mindset of asking themselves what it would be like for their horse or animal. Secondly, it can be used in a more productive manner as a catalyst to brainstorm, or as in human-computer interaction, we often say body storm, because we like to include the whole physicality of the body, not just the brain. You could brainstorm or body storm requirements for a real system. For example, if you were a horse, would you want to walk through that gap? Would you be frightened of that mechanical sound? Allowing yourself to think like the animal that you designed for is very important. Other options. These are, again, methodologies of ACI, things that we need to consider in a multidisciplinary area. A new hybrid approach representing this interdisciplinary nature of ACI. Amalgamating quantitative and qualitative methods into a new hybrid approach. Now, I've called this Ethographology, which is describing and studying the fundamental behavior of a species. So it breaks down into Eth from ethos, fundamental behavior of a species, graph describing, like ethnography, and ology to study. Ethographology, our partners and I from Habit have described that in a paper called Multi-Species Ethographology from Ethnography to Ethology via Horses and Videos, but it's been out and might be published somewhere soon, I hope. There have already been attempts to name methodologies that combine elements of ethology and ethnography. I think they're ethnography and ethnoethology. And in both cases, they're not actually about combining the elements into one new hybrid. It's about using one approach or the other as applied to either human animals or non-human animals. But if you have a search, I'm sure you'll find out more on that. More on this. A new hybrid approach, ethographology. So ethographology takes from both ethology and ethnography. From ethology, it takes observation, logging, ethograms, behavior frequency counts, visual representations of logging data, things like box and whisker plots. From ethnography, it takes things like, or certainly the ethnomethodology used that we use in computer science, things like data sessions around videos, arranging informal researcher meetings, if possible, involving colleagues from beyond the immediate project team as fresh eyes, written emergent narratives, descriptions of vignettes, behavioural snapshots, which attempts to describe what might be happening in the video with examples and context. So here are some example steps of ethographology combining those approaches. So step one is video multi-species interaction in the wild. So in the wild, which is, I'm sure it's something used in anthropology and anthrozoology, but we use it in HCI as well, so that we're talking about things outside the lab, in the field. You go out and you collect a lot of video data of your species interacting with each other, or sometimes, in our case, species interacting with technology as well. You then interview, semi-structured interviews, the human animals about these interactions, because they're the ones who have spoken and written language and can do that. They have a voice. Most humans have a voice. We then conduct data sessions around videos. This is where researchers discuss the raw video, identify short video vignettes illustrating recurring interactions and behaviours spotted in the videos. We then produce written attempts to describe what might be happening within each video vignette or behaviour. We build and refine a new ethogram to describe the interspecies interactions observed, comparing them possibly with the baseline behavioural repertoires for the individual species. That way, if you know what's within the range of a species that isn't interacting with another species, then you have some idea if this is new behaviour that you only see when they're in part of this interaction mode. Using the new ethogram, observe the video and log counts, durations of specific behaviours, repeat with several raters. That means you literally, with either with a pen and paper or a bit of software, you sit down and you watch the video and you go through looking for behaviours in your ethogram, and every time you see one, you note down that the behaviour has occurred, and you probably log the duration of it in most cases as well. Repeat with several raters means a rater is the same as an observer, and in this kind of system which could be considered fairly subjective, it's a good idea to use several different people and see whether they're seeing the same behaviours in the video, and that way you can do that. And then when you do your analysis at step 7, your stats, you can also do a check for inter-rater reliability and agreement to make sure that within acceptable parameters the raters all agree on what they're seeing, that they are seeing the same behaviours from the ethogram. Of course, you can create graphs and other visualizations to support this as well, and then you present the data combined with a qualitative context that you've been generating from the interviews and from the vignettes and the things that you've written up earlier. So we're finally getting on to what is habit, which my project, Horse Automated Behaviour Identification Tool. This is about considering the use of technology to automatically recognise horse behaviours. An objective is to automate the analysis and recognition of horse-to-horse and horse-to-human behaviours as observed in YouTube quality video. And we're asking questions like, are horses interacting with their human companions as if they were other horses? There are reasons why we might want to ask things like that. One of them is that in natural horsemanship training systems such as Pirelli, that I have been involved with and I'm trained in, it's often described that horses are being trained and responding to a human during interaction as though they were another horse. And there's not a lot of science to actually support that. It's much more likely that they're simply responding in a more mechanistic manner to operant conditioning through negative and positive reinforcement and the other quadrants. But this is still a much said thing, that you can train a horse to view you as being its alpha or the herd leader or something, and if it recognizes your leadership, it will behave in a certain way. So by having a method to consider whether horses are behaving in the same way with humans as they are with other horses, and doing this automatically so that it's through software, there are huge advantages to this, and it's a particular interest to equitation science as a field. There's also assessing equine behaviour from a welfare perspective. We can point this system, the tools from this system, at horses in different situations, in transit, at sporting events, competitive horses, race horses, and really get a clear picture of whether they are comfortable acting within their normal range of behaviours. Are horses in training generally, even if it's with an owner at home, are they behaving normally? The partners in habit, my academic partners, come from computer science, but also from the animal sciences, from equitation science, and in the vet school world, from biomechanics and animal behaviour. So this is intended that the habit tools should work with domestic quality video, things like YouTube, phone quality, to make it as accessible to as many people as possible, and not limiting it to costly hardware. It becomes easier if you use expensive graphics cards and graphics processing units. You can do a lot of stuff, but that's not something that we're going to be able to roll out to lots of different people. Okay. So the elements of the habit system. There are helper apps that provide a smooth workflow. They do this by processing longer clips in longer video excerpts into shorter clips, ready for analysis by the main system. And there's actually some horse recognition that goes on in that I have a system for summarizing longer video, a bit like highlights from sport, and it can automatically go through and pick up bits that have horses in with different levels of activity, so we can look for the more energetic bits of the longer video, and it will automatically chunk these down into short clips ready for processing. Then there's the main system, which is identifying the actual equine behaviors from unconstrained video. And unconstrained video, I mean YouTube, things like that, not something that you've shot in a controlled environment in the stable or lab. So where are we up to with the software development on this? Well, we had short-term funding, which is long run out, and now at this point the partners and I are putting our own research time into this, so things are moving more slowly than they were. I do patches of development when I can. The helper app aspect of this is largely completed. The main system, we have the concept sorted out, we have some coding and some elements working, but there's still quite a lot to do. There's many months of programming and refining to get it working in a reliable way. It's things like habit and behavior recognition are not just for human animals, nor should the overall methodologies that I was suggesting earlier necessarily be. Through embracing otherness and my idea of ethnographology, these are useful methods for working with all types of unaware interactors. These are individuals who are not using the system implicitly, not just using it implicitly, which means that they know what a computer system is, but they don't know that they've just triggered it. That would be an implicit user. The explicit means you go up, you touch screen, something happens. Implicit means you're in a shopping centre and a doorway opens for you automatically. You didn't know you triggered it, but you do know what a computer system is. But unaware interactors are interacting with systems and don't even know that there is a system or have no concept of it. They're unable to conceptualize its formal function. So this applies to non-human animals, but it also applies to some humans, infants, the elderly, neurodiverse human animals. And there are obviously implications for the parent field, although that is arguable, of ACI, human-computer interaction, because they're looking at exactly these questions with humans, and at the moment they don't have a way to do this other than the approaches they would use based on the ethnomethodology of asking questions. And so in some ways these human animals are being cut out of the discussion and not contributing to the design of systems in the same way that non-human animals are, and it's something I feel quite strongly about. So, reaching a bit of a conclusion, but we're not quite done yet. We've looked at techniques to enhance empathy with animals, including my design fictions. I've suggested and proposed a new hybrid methodology for animal-computer interaction, which amalgamates quantitative and qualitative methods. This is ethographology. And there was an example earlier when I went through the several steps of how that would happen. Empathy with animals, challenging anthropocentric assumptions, and using the hybrid methodology may help us to avoid unconsciously projecting our personal design priorities and enthusiasms onto users. This is obviously in the design of systems, but I'll say more about that in a minute. Lessons learned about user-centered design for unaware interactors, people who don't know, humans and animals who don't know what they're using, may be transferable to human-computer interaction research, working with vulnerable neurodiverse human animals. So in ACI, I'm arguing build only what they want or need. In Athrozoology, I would argue that this translates to observe only to improve their lives. So in both cases, we have to keep remembering why we do it and the ethical significance of the animals that we're working with. I have some final questions for you. So I'm hoping you might want to discuss this, but you can also ask me other things about the presentation as well, about ACI, about Anthrozoology and computers. Okay, so far animal-computer interaction has not attracted researchers working on mechanisms or mechanization in factory farming or animal experimentation. It could happen. Many ACI researchers would be appalled if this actually happened. However, there are ACI researchers who develop technologies for working animals, custom search dogs, cancer detection dogs, and even, and this is the one that bothered me, explosive detection dogs. We're putting dogs knowingly at risk for the benefit of human animals, but the dogs have no choice in the work that they're being asked to carry out. What do we think about this? Should a field interested in interactions between animals and technology take on an ethical stance? Should it be okay to exclude specific lines of research? Where would you draw the line if it was you trying to decide this? If you were involved in ACI, would you be arguing or lobbying for this to be changed? Aren't working animals still being exploited if they're cancer detecting, if they're explosive detecting, however reasonable their training and treatment? But what about if an individual animal actually enjoys his or her job? Does that make it okay? What do you think? These are the kind of questions I would like you to consider. So I'm going to leave it there, but if you want to ask me about that, we can go on and chat about it more. That's great. Thank you.